Hello friends, this video on NEET in alternating current is brought to you by examfear.com. No more fear from exam. Bulb 500 watt 100 volts is to be used in a 230 volt main supply. When a resistance R is connected in series, it works perfectly and the bulb consumes 500 watt. The value of R is... Okay, so let us first understand the circuit. So you basically have a circuit where you have a bulb. Okay, and you also have a 230 volt main supply, somewhat like this. So this is your 230 volts main supply. Okay, and there is also a resistance R which is connected in series like this. So this is your resistance R. Okay, now we have to calculate the value of this resistance R, and we also know few details about the bulb. Okay, now let us first focus only on the bulb. So what are the things that we know for the bulb? So we know the power of the bulb, which is 500 watt. We also know the voltage across the bulb, which is 100 volts. Right? Now with these two values, can we calculate the resistance of the bulb? Because the bulb as an appliance itself will also have some resistance. Right? So let us first calculate that resistance of the bulb, because as if you consider the entire circuit as a whole, you might need to calculate the equivalent resistance of the circuit. So for that, it is must that you know the resistance across the bulb. So let us first calculate the resistance of the bulb. So we know that power is equal to V square by R. So now, right now we are just focusing on the bulb. So we can say that RB will be equal to VB square by PB. So VB is equal to 100. So 100 into 100 divided by 500. So this will be equal to 20 ohms. So now we know the resistance of the bulb. Fine. Now let us try to calculate the amount of current that flows through the bulb, because the same amount of current will flow through the bulb as well as through this unknown resistance R. Right? So the current that will flow through the bulb will be given by VB by RB as per Ohm's law. So we know that V is equal to IR. So using that, we can calculate the current flowing through the bulb. So VB is 100 and RB is 20. So this is equal to 5 amperes. So 5 amperes of current flows through the bulb. That means the same 5 ampere of current will also flow through this resistance R. Now let us focus on the overall circuit. So right now we are no more focusing only on the bulb. So for the overall circuit, we can say that the voltage across the circuit is 230 volts, which is equal to I, that is the current flowing through the circuit, which is again the same current which is flowing through the bulb, into the equivalent resistance of the circuit, that is R plus RB. So from this we can say 230 divided by IB is 5 is equal to R plus RB is 20. Or we can say R is equal to 230 by 5. So this is equal to 46. So R will be equal to 46 minus 20, that is equal to 26 ohms. So the correct option is C. Question number 2. The potential difference across a resistance, capacitance and inductance are 80 volts, 40 volts and 100 volts respectively in an LCR circuit. The power factor of this circuit is... So what is power factor? Power factor is cos phi. Now this is an LCR circuit. Okay, so in LCR circuit, how do we calculate phi? Using this expression, tan phi is equal to XL minus XC divided by R. Now we have, from basic trigonometry, we learned that tan phi is perpendicular by base. So if we have to calculate cos phi, that will be equal to base divided by hypotenuse, which is equal to root over base square plus perpendicular square. So this is cos phi. But unfortunately, in this problem, we are not given any of these values, resistance or capacitive reactance or inductive reactance. So what do? So we need to somehow derive an expression where we have the voltages across these elements. So what we do is, We do a simple thing. We just multiply the numerator and the denominator by I, the current that will flow through the circuit, because it is an LCR circuit. So you have the inductor, you have the capacitor, you also have the resistance. Now since they are all in series, so the same amount of current will flow through all of them, right? So let us multiply the numerator as well as the denominator by I. And if we do that, this is how it looks like. Now we will do simple mathematics. Now if I want to put this I inside, what will happen? It will turn into I square. So this is how it would be like. So now this can be written as IR divided by root over IR whole square plus, now this I, if I want to put it inside, I can write it like this, IXL minus IXC whole square. So now what is IR? IR is nothing but voltage across the resistance R. So this will be VR divided by root over, again IR can be written as VR square. Now what is IXL? XL is the net inductive reactance. So I into XL is nothing but voltage across the inductor. Similarly, IXC is nothing but voltage across the capacitor. So now you see we have arrived at an expression where we have VR, VL and VC. Now if you look at the question, here 80 volts is the value of VR, 40 volts is the value of VC and 100 volt is the value of VL. So now all that we need to do is just put this value. So this will be equal to 80 divided by root over 80 square, that is 6400, plus VL minus VC. So 100 minus 40, that is 60 whole square. So this is equal to 80 divided by root over 6400 plus 3600. So this is equal to 80 divided by root over 1000, which is equal to 80 divided by 100. So this is 2 4s are 8, 2 5s are 10. So 4 by 5, which is equal to 0.8. So the correct answer is C. Question number 3. A small signal voltage Vt is equal to V0 sine omega t is applied across an ideal capacitor C. So now you have 4 options. Option A, over a full cycle the capacitor does not consume any energy from the voltage source. Option B, current is in phase with voltage. Option C, current leads voltage by 180 degree. And option D, current lags voltage by 90 degree. Now here, looking at the question, you can see that it is talking about a capacitive circuit. Now quickly recall the phase relationship between voltage and current in a capacitive circuit. So C for capacitor, C for current. So in a capacitive circuit, the current leads voltage by 90 degree. So that's the correct phase relationship. Now let us look at these options one by one. Current lags voltage. So this is incorrect because current leads voltage. Option C, current leads voltage by 180 degree. So partially it was correct, but it is not by 180 degree, it's by 90 degree. So option B, current is in same phase with voltage. No, that is absolutely incorrect. So anyways, now we are left with option A, which has to be correct. But let's see, what do we mean by the option? It says over a full cycle, the capacitor does not consume any energy from the voltage source. That's absolutely correct. Because we have also learned that when we calculate the average power consumed in a cycle, we see that in case of a capacitive circuit, since the phase difference is equal to 90 degree, therefore the power factor is equal to 0 and therefore the average power consumed over one cycle is equal to 0, which means that the energy spent over one full cycle is equal to 0. So therefore we can say that over a full cycle the capacitor does not consume any energy from the voltage source. So A is the correct option. Question number 4. An inductor 20 millihenry, a capacitor 50 microfarads and a resistor 40 ohms are connected in series across a source of EMF V is equal to 10 sine 340t. The power loss in AC circuit is. Now let's again quickly recall, how do we calculate power associated with an AC circuit? So power associated is equal to Vrms into Irms into cos phi. right? So our first challenge would be to calculate the value of cos phi. So we already know that tan phi is equal to xl minus xc divided by r, which is equal to omega l minus 1 by omega c divided by r. As we have discussed before also, that using simple trigonometry we can calculate cos phi as r divided by root over r square plus omega L minus 1 by omega C whole square. That's because tan phi is perpendicular by base, cos phi is base by hypotenuse, and hypotenuse is equal to root over perpendicular square plus base square. Okay, so now let's try to calculate this part by part. Now what about VRMS, RRMS, so IRMS? So how do we calculate this part? So let's focus on that part. So VRMS, IRMS, this can be written as, so what is V multiplied by I? That is nothing but apparent power. So this can also be written as VRMS square divided by Z, because IRMS, I can be written as V by R. And what is the net resistance of an LCR circuit? It is the impedance, which is denoted by Z. So now VRMS, how is VRMS related to V naught, that is the peak value? We have learned that VRMS is equal to V naught divided by root 2. So here we can write V naught square divided by root 2 square, which is 2. This into Z. Right? Now, do we know the value of V naught? Yes, we know that, because here it is given V is equal to 10 sine 340t. So this 10 is nothing but V naught, right? Okay, so now let's calculate the power. So this will be equal to, instead of VRMS, IRMS, we will write V naught square divided by 2 into 1 by Z. So instead of Z, we can write root over R square plus omega L minus 1 by omega C whole square. So that's how we define Z. Now this multiplied by cos phi, that is R divided by root over R square plus omega L minus 1 by omega C whole square. So you see both of these are the same terms. So 2 root overs. So this can be written as V naught square into R divided by 2 into R square plus omega L minus 1 by omega C whole square. So now do we have all the values to calculate this? Yes, we do have. V naught is equal to 10. R is given as 40 ohms. Again, R is given as 40 ohms. What is the value of omega? Omega is 340, because it is V is equal to V naught sine omega t. So omega is 340. L is given as 20 millihenry, that is 20 to 10 to the power minus 3 Henry. Again, omega is 340, and C is given as 50 microfarad, that is 50 into 10 to the power minus 6 farads. So when you put all of these values and do the calculation, you get the answer approximately equal to 0.51 watts. That is option D. Question number 5. A resistance R draws power P when connected to an AC source. If an inductance is now placed in series with the resistance such that the impedance of the circuit becomes Z, the power drawn will be. Okay, so here in this question, we are talking about two different scenarios. So in the first scenario, what is happening? We have a resistance R which is connected to an AC source like this. So in this case, the power drawn is equal to V square by R. So here R is the value of this resistance. So this is our scenario 1. What happens in scenario 2? So in scenario 2, an inductance is placed in series. So basically in next scenario, you have an inductor which is placed in series with the resistance like this. So this is inductor, this is resistor, and this is the AC source. So in this case, what is the power? So the power in this case would be V square by Z, because now the net resistance of the circuit is basically the net impedance of the circuit, and also now you will have the power factor cos phi, because the moment you have two different elements involved, you have resistance, you also have inductance, so now you also have the power factor cos phi, right? So what will be cos phi? So we need to calculate that as well. Okay, so now we know that tan phi, so we know that cos phi in this case would be equal to R upon Z right? So that would be the value of cos phi. So therefore, now here you might ask that how cos phi is equal to r by z. So we know that tan phi is equal to xl minus xc by r. So here there is no capacitance, so tan phi will be xl by r. So cos phi will be equal to r divided by root over xl square plus r square. Now what is this basically? This is basically the net resistance of this circuit, that is the net impedance. So cos phi is equal to r by z. So therefore we can say that the new power, that is P dash, is equal to V square R divided by Z square, or we can write it like this. Instead of V square, what can we write from this equation? Instead of V square, we can write P into R. So P into R divided by Z square, that is P into R by Z whole square. So that is A is the correct option. Question number 6. A condenser of two. Thank you. Please visit examfear.com for free quality education. You can learn with a simple 4-step learning process wherein you can watch video lessons, you can ask your questions, you can refer notes, and you can take a free online test. We have content for class 6 to 12 on physics, chemistry, mathematics, and biology along with practical videos. So please subscribe to our channel for daily updates. Thank you.